Imagine drifting silently through the vast emptiness of space, the cold void stretching infinitely in every direction. You're alone, with nothing but the stars as your companions. Suddenly, ahead of you, a tiny pinpoint of light begins to grow, ominous and brilliant. You realize it's not just any star, it's a neutron star, a remnant of collapsed supernova, a body so dense, so powerful, that a sugar cube-sized piece would weigh as much as Mount Everest. What if you found yourself pulled inexorably toward this cosmic abyss? Could you survive? Or would you be obliterated before you even reach its surface? In this journey, we'll explore the terrifying, the fascinating, and the scientifically mind-bending reality of falling into a neutron star. Buckle up, because what you're about to hear might just shatter everything you thought you knew about our universe. Neutron stars are born from destruction, the explosive death of a massive star. When a star exhausts its fuel, its core collapses under gravity's relentless pull in a supernova explosion. What remains is an incredible object, compressed to a point where the density exceeds anything found on Earth. This core is packed with neutrons, particles so tiny yet so tightly bound that they create a star-like object with a diameter of only about 20 kilometers, roughly the size of a city, but with more mass than our sun. Discoveries of neutron stars have always fascinated scientists. The first confirmed neutron star was detected in 1967, pulsing with a regular rhythm, known as a pulsar, which acted like a cosmic lighthouse, revealing the extraordinary physics inside. Their magnetic fields are trillions of times stronger than Earth's, and their gravity warps space-time itself. Imagine boarding a spacecraft designed for this perilous journey, hurtling toward a neutron star at a significant fraction of the speed of light. As you approach, the intense gravity begins to work its magic. The star's gravitational pull is millions of times stronger than Earth's, so powerful that the very fabric of space-time curves uncontrollably. The space around the star heats up to millions of degrees, creating a blazing atmosphere of superheated gases. Yet, as you hurtle deeper, the real nightmare begins. The star's crust, made from a dense lattice of atomic nuclei. It's a fortress of nuclear pasta, unimaginably dense material that defies ordinary physics. This crust is only a few hundred meters thick, but acts as a final barrier before the star's terrifying core as you venture further inward. You feel the cruel reality of gravity's relentless power. The core's gravity is so extreme that it begins to stretch and distort your body in a process scientists call spaghettification. Your body elongates. Your limbs are pulled apart as if a giant hand is stretching you into a thin strand of spaghetti. Meanwhile, the immense gravitational gradient, difference in gravitational pull from your head to your feet, becomes so brutal that it could rip your body apart in seconds. For planets or ships, it would be catastrophic. For your body, it's the beginning of an ultimate transformation, a journey into the unimaginable. Beyond the crust, you enter a realm where matter behaves in ways that baffle even the most advanced scientists. The core is composed of neutron-rich matter, so dense that the protons and electrons are combined into neutrons, forming a neutron liquid. This isn't just normal matter. Inside, you encounter nuclear pasta, structures so dense they look like bizarre arrangements of spaghetti, lasagna, and gnocchi, formed by the intense gravitational compression. Unimaginably, some theories suggest the presence of strange quarks, exotic particles that could form strange matter, an even more stable form of matter that might convert everything it touches into more strange matter. This process could be catastrophic, transforming you into part of the star's strange, dense interior in moments. Falling deeper into a neutron star is akin to an unavoidable cosmic purge. Your physical body would disintegrate under the extreme pressures, temperatures, and forces. The strong nuclear forces and gravity combine into a destructive force that no human or machine could withstand. If somehow you survive the initial plummet, you face the ultimate destruction. being part of a cosmic core where the laws of physics reach their limits. It's a realm where time itself may slow or even break down, where known physics no longer applies, and where the universe's deepest secrets are hiding. But why imagine such a terrifying scenario? Because neutron stars are cosmic laboratories, perfect for understanding the universe's most extreme physics. They help us probe gravity, nuclear physics, and the nature of matter itself. Even as we cannot survive a fall into one, studying neutron stars expands our... The neutron star, though mysterious and deadly, is only one kind of strange object lurking in the universe. Let's step back and imagine the life of the star that came before it. The giant star spent millions of years fusing hydrogen and heavier elements deep in its core, a brilliant beacon in the night sky. But as its fuel ran out, the blindingly hot glow dimmed, and its core's gravity won the battle against outward pressure. Gravity crushed the core with unfathomable force. In moments, the star's outer layers erupted in a colossal supernova, a death cry illuminating the cosmos for miles. What was left behind, small, dense, and spinning rapidly, was a neutron star you dare to approach. Now, imagine what's happening as you draw near the star. Space itself warps unpredictably. Light bends, time dilates, and your senses reel with incomprehensible phenomena. What your eyes see, your instruments measure, none behave like normal. Approaching the neutron star, you start to feel gravitational tidal forces stretching your surroundings drastically. Imagine standing with one foot on a mountain and the other on the plains below. The difference in gravitational pull is immense. In this cosmic analogy, your head experiences far stronger pull than your feet, so your body stretches like taffy, a process dubbed spaghettification. It's no simple stretch, but a gruesome elongation that would pull you apart molecule by molecule. As you descend past the surface, you enter the star's crust, a few hundred meters thick, yet composed of matter so dense that a single teaspoon weighs billions of tons. This crust isn't smooth. It's fractured and crusty, cracked under immense magnetic stresses. These giant starquakes, like cosmic earthquakes, release bursts of X-rays and gamma rays, signaling the star's restless energy. Within seconds, or what seems like seconds to you, your body encounters pressures far beyond anything on Earth. Think about the crushing force that can flatten mountains. Here it's millions of times stronger, pushing atoms so close that electrons are forced inside atomic nuclei, combining with protons to form neutrons. You become surrounded by a sea of densely packed neutrons, particles that give the star its name. But the neutron star's interior may hide even stranger secrets. Some physicists theorize a core made not just of neutrons, but quark matter, a strange plasma where quarks roam free. Quarks are the fundamental building blocks of protons and neutrons, but under these conditions, they might exist unbound, in a state unheard of anywhere else. This quark gluon plasma would defy all everyday understanding of matter. Imagine yourself submerged in this extreme quantum soup where normal atoms leave no trace. It's a theoretical journey to the earliest moments of the universe, a communion with the first fractions of a second after the Big Bang. As you ponder this, think about time itself. Near the neutron star, Einstein's relativity becomes sharply visible. Time dilates, meaning time for you could pass minutes, while years tick by elsewhere. From your perspective, the outside universe might speed up or slow down in bizarre ways as gravity's grip warps space-time. Now, picture the star's powerful magnetic fields. Some neutron stars, called magnetars, have magnetic strengths 1,000 trillion times stronger than Earth's. These magnetic monsters can rip atoms apart from hundreds of kilometers away. If you fall toward one, magnetic forces would ravage your body at a subatomic level far before gravity finishes its work. Magnetars can unleash giant flares, bursts of high-energy radiation that temporarily blind even the strongest satellites in orbit around Earth. To survive near one isn't just impossible, It's unimaginable. Despite this deadly reputation, neutron stars fascinate scientists for their role in the cosmic ecosystem. They are factories for the universe's heaviest elements: gold, platinum, and uranium, materials vital to planets and human civilization, are born in the violent collisions of neutron stars. In recent years, gravitational waves, ripples in space-time predicted by Einstein, have been detected from neutron star mergers. These observations open a new way to listen to the universe, revealing energetic cosmic events invisible to traditional telescopes. Neutron star mergers also produce bursts of gamma rays, short but powerful emissions that test our understanding of physics. Imagine, on a far horizon, humanity devises ways to monitor neutron stars even more closely, using signals across the electromagnetic spectrum and gravitational waves. Perhaps one day robots or probes could brave the outer atmosphere of a neutron star, recording data where no human could survive. But what questions remain? What does the core look like? Is strange matter stable? Could a collapse ever continue to form a black hole? These unanswered mysteries fuel astrophysics research, experiments, and simulations. Back to you, plummeting through space toward the star's surface. Gravity's grip tightens. Your molecules begin to dissociate. Your individual identity as a human being, your body, your mind, wants to cling to stability, but fundamental forces tear you apart. Yet, paradoxically, as your physical self disappears, your story joins a grand cosmic tale. The atoms that once made you, transformed, may one day become part of new stars, planets, or even life elsewhere. The neutron star embodies the cosmos' relentless cycles of destruction and creation. It is a reminder that the universe operates on scales and with powers far beyond everyday life, but also that life itself is intimately connected to these cycles. So what lessons can we take from this terrifying thought experiment? It teaches us humility and marvel. The universe is not safe, predictable, or small. It is wild, mysterious, and beautiful in ways we are only beginning to grasp. As you imagine falling into a neutron star, you feel the limits of human endurance, the boundaries of physics, and the depth of cosmic wonder. This journey might be fatal, but it is also a vivid reminder. The universe is waiting, vast, mysterious, and full of secrets. From here on, we can only wonder what other cosmic extremes await discovery. Strange quark stars, black holes at event horizons, or something entirely unknown. Your fall into a neutron star is but one of many fantastic, what-if scenarios that challenge our imagination and science. And so this story ends not with an ending, but with a question. How far will humanity push, explore, and understand? How many mysteries will we unravel before we fall ourselves, metaphorically, into the depths of the cosmic unknown? Beyond the intense and bizarre core, imagine what lies even deeper, at the threshold of the unknown. The forces here could alter the very nature of matter itself. Physicists theorize about quark matter, a soup of fundamental building blocks of the universe. These quarks flow freely, no longer confined inside protons and neutrons, echoing the conditions just after the Big Bang. Now, picture your molecules breaking apart, atoms scattered, your very identity dissolving. This ultimate transformation is not just destruction. It's a journey back in time, the primordial stew that formed every star, planet, and even life itself. Falling into such a realm raises deep questions. What is matter truly? What is consciousness if the physical body can be so thoroughly undone? At this cosmic boundary, science merges with philosophy. Are you still you when stripped to your most fundamental particles? Outside of this personal nightmare, neutron stars tell an incredible cosmic story. They spin hundreds of times per second, emitting streams of electromagnetic radiation. These pulsars act as celestial lighthouses, enabling scientists to measure time and test the limits of physics with extraordinary precision. Some neutron stars even help confirm Einstein's theory of general relativity, providing evidence of how gravity warps space and time. Now imagine a pair of neutron stars locked in a furious, spiraling dance, a binary system. Their gravitational bond pulls them slowly closer over millions of years. When they finally collide, the resulting explosion creates cataclysmic energy bursts and ripples through the universe in the form of gravitational waves. These collisions also forge the heaviest elements, gold, platinum, uranium, spreading them across galaxies and seeding worlds like ours. This cosmic forge shows us how the universe's most violent episodes also create the beauty and raw materials essential for life. Your fall into a neutron star might be catastrophic, but these stars are at the heart of stellar creation and cosmic transformation. Let's focus on their magnetic fields. Neutron stars can have the strongest magnetic fields in the known universe, billions of times more intense than Earth's. These fields can twist and shear the star's crust, causing sudden starquakes and releasing titanic energy bursts. Some neutron stars, called magnetars, emit flares bright enough to briefly outshine entire galaxies. The magnetic forces of such an object would shred your atoms before gravity could finish the job. At such extremes, even the notion of falling loses meaning. Space and time themselves warp and stretch. Time dilation occurs. Seconds near the neutron star might stretch into years far away, or vice versa. It's a realm where the laws of reality twist beyond recognition. Our journey highlights the limits of technology and imagination. For now, neutron stars are unreachable except through radio telescopes, X-ray satellites, and gravitational wave detectors. But what if, in the distant future, humanity develops ships tough enough to approach? What wonders and dangers will we discover? Could we harness their energy, or would we risk everything just by coming close? While falling, it means annihilation. The quest to understand neutron stars inspires humility and wonder. These cosmic objects remind us of our small place in the universe and the grandeur all around us. They urge us to keep questioning, dreaming, and pushing past boundaries. Next time you look at the night sky, imagine the invisible titans out there, collapsed giants, spinning silently in the dark, shaping galaxies and the very matter that makes up your world. What if you fell into a neutron star? It's a terrifying scenario, but also a doorway to the greatest mysteries in nature. The universe is vast, strange, and bursting with wonders we are only beginning to comprehend. As you listen to this, remember, your story is connected to the stars, written in the same cosmic code as those extraordinary neutron stars spinning in the dark.